Hi guys, nice to see you again. Before I start anything today, I'd like to send you my best wishes for the end of the year. And together with that, and besides your health, I'd wish you also for 2024 to bring you a lot of this. And also better display controls. I know that last time I told you we're going to discuss the breathing control today, the breathing control. But for the end of the year, the last video is going to rather be a flashier one. We're going to analyze together the big display 7 inches size and everything it can do for you. Let's start it. The first information is, where can you find it? You go in qkits.com, qkits.com, and when you do, there is a category here, electronics, the first in the top, and you go until you find the icon LED LCD displays. You click on it. You don't know what you're looking for, it doesn't matter, just scroll it. Here is the famous 16 segment displays, 2.3 inches, 2.3 inches size. It's not this one for today. We go further, next page. And then, by scrolling, you are gonna find this guy here. 5 inches, 7 segment display. $25 approximately, Canadian dollars. Is this guy. I just ordered it, didn't take it out of its plastic foil. It's right here, but it's not this one we discussed today. This is the one. 7 inches, 7 segment display module. Okay, it's called MXA003. The other one was 002. You see, MXA002. Okay, if you want to put it on a piece of paper, is MXA003, and I have one right here, ordered together with the other one, and we're going to open it together and analyzing everything it can do for you, okay? So, here you find it. Now let's go and analyze it. Okay, so we're going to open this one, removing the plastic foil. Right here in the back, it comes with a piece of paper. We're going to remove the staple, keeping it in place. Okay. All the basic documentation is over here, but I'm going to quickly explain it to you because I'm prepared already. Let's consider first the little guy, 5 inches, because 5 inches size and 7 inches, they are organized absolutely similar way. There are a couple of jumpers explained here, J1, J8, and they are the same here, J1, J8, so it's going to be the same. The segments can be energized in 2 basic ways, 12 volts or 24. So now, how is this made? All the resistors are already in place on both boards, so on the big one and on the smaller one, and the resistors are here, 220 ohm. I'm gonna start with this one here. One segment for this small one, 5 inches, is made of 1, 2, 3, 4, 5 LEDs here, and 1, 2, 3, 4, 5 LEDs here. So 2 groups of 5. As prepared here already, the 2 groups of 5 with the 220 ohm resistor already attached. if you energize the 12 volts, I'm going to call this a string of diodes. And the second string, they are going to be related together. It's going to be one leg here and another one here. So the two strings are going to go in parallel. So this is why one segment is going to have one segment. Is going to have 10 LEDs. In the moment you want to go on the jumper to redo the link to energize the 24, is going to be one end here, and then the end of this one is going to come together with this one here. So the two strings are going to go in series this time. So as they go in series, as you can see, the size of the resistor doubles, because 220 ohms in series with 220 ohms. And the second leg is going to be here. And that's how you can energize it at 24 instead of 12. So it's going to be, again, one segment. But the position of the two strings is going to be the same. The position of the two strings is going to be the same. So this was the small one, 5 inches size. What's making the difference is the one we discussed today in detail, the 7 inches size. This one, instead of having 5 LEDs for each string, it has 10. So this one is going to have 20 LEDs per segment. One string and the second one, okay, if you count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the other string, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are making together one segment. 10 LEDs per string, 20 LEDs per segment, okay? So that's the first thing to know about it, okay? So far, so good. So basically, this is the description of it. Now, the second thing which is very interesting about it is that this kind of display is designed in such a way that here where the links are, you can configure it to use as a common anode or as a common cathode. Unfortunately, even if the distance between the holes where you put the wires is 0.1 inches, which is good, for me it's like a, let's call it, unfinished project, okay? Because it could have been done a bit better to allow you establishing the way you make the links yourselves. As I'm preparing here on another project for the next year, some dual inline little switches, and by attaching such a thing right here, we should be able to improve, let's say, the functionality of this display. And this is what we're going to do now, okay? So if you consider these two ways to do it, right here, there are the two rows of contacts already prepared, like these ones and these ones. Is one contact for each of the segments. They are not arranged in the order we expect: A, B, C, D, E, F, G. It doesn't matter, and the decimal point. It just doesn't matter. But they give us the letters corresponding for each of the positions. Okay? And what we're going to do, of course, we can still configure it to be common anode or common cathode. This is not a problem. Okay? Excepting, I'm going to show you by placing this dual inline mini dip switch block, this one here, how can we improve the functionality for it, okay? So the thing is, in order to insert this one here, because right now we have here the anode for D and the cathode for D, we cannot short them, because if you put a switch here between and you short it, the diode is not going to lit up, okay? And for that reason, we have to modify just a bit the circuitry here inside to have it done. So the first thing we have to do is to pick up quickly a little scratcher, and I'm going to prepare this one by removing the ink on a short distance. You see, I'm removing the ink, protecting the printed circuit. So I'm going to do this for each of the lines corresponding to the segments. Don't worry, it won't take long. Okay. We're going to see better in a couple of seconds. And this is the last one. Okay. Okay, now we're going to be able to see better this thing. And what we're going to do, I'm going to use this one here in the bottom. As you can see here, I cleaned all the traces of the circuit board. And now I'm going to cut one by one the traces between the pad and the circuit board, because I need here to create an open circuit, okay? So I'm going to use a scratcher to do this. One by one. We're going to double check at the end that all the links are broken. Let me check them. First one is surely done, second one is done, third one is done. There's the fourth one right here. Fifth one. Sixth one. Seventh one. And we're going to cut here the eighth one. You have to be careful to not cut anything else, but just these 8 links. Corresponding to the segments plus the decimal point. Okay, let's consider it done. If it is true, we're going to check it. Okay. So then, good, this is when it's shorted. Now I point it here. That's good. No sound, no sound, no sound, no sound, no sound, no sound, no sound. Good. So it seems the links are broken. And then, next step is we're going to use a little desoldering pump, and we remove the solder from the pads to liberate the holes underneath. You see here, there is a little hole. That's what we're going to do to all of them, okay? Because there we need to insert our mini dip switch package. So we need the holes liberated. And on the other side. You won't take long. Okay, one more. Okay, right now we clean it. So we liberated the holes, okay? And now we have to be careful because the distance between the two rows, which should be 0.3 inches, on the actual printed board of our digit is a bit narrower. And also be careful because they say here the segments, it doesn't matter, they are not in order, but there are 7 of them up to here. P is from decimal point, V is for voltage, so we are going to leave these 2 holes free, and we try to place it in the holes starting from my left, okay? So that's how we insert our dual inline package. Be careful, try to not push on the switches themselves but on the sides. Now we take a look here, they look okay. What we're going to do, we're going to solder the bottom row, because now we liberated the holes just to place the package. Okay, and we fill back with solder on each of the holes on the bottom row. Okay, this one is done. We double check it. We don't want anything else in between. Okay, and then we're going to make the common cathode. Don't worry, I'm going to explain it again on the drawing as soon as I finish to solder. Okay, so we start from here. and we solder one end right here. Okay. And we're going to place the other end up to here, where is going to be the common. Okay, good. Somewhere in the middle. Excellent. So once we do that, I'm gonna be able to fill the other ones with solder. So this time, one end of the switches is gonna be really shorted by that piece of wire to create the common cathode. So we go now for the version of the common cathode of our display. Okay, done. Okay, so once this thing is done, I'm gonna be able just to cut it here to the end. This part is shorted. And now I'm going to put some solder where I removed the ink, because here we also need to solder some wiring. Very good. We're double checking to make sure the circuit is still open between the traces we cut from the common. We're going to hear the sound like this. That's it. So we don't need to hear the sound from the common. Very good. See, if I put it here, it's going to cry. And now we check again to make sure all these links are cut. Okay, very good. And right now, because we want to replicate the functioning of one such, we want to replicate the function of such 7-segment display like in the number we created in the previous videos, like the civic number. I'm going to put together these anodes. Don't worry, because this wire can be desoldered anytime I want. Okay. Okay, this one here. Okay. I just want to reach also the last of the links right here. Very good. I'm going to solder it as well. And now I'm going to put solder on the missing links, just to make sure I'm reaching all of them. That's it. Very good. So now, once I have them prepared, I'm very close to the end. From an old computer motherboard connector, I'm gonna need 2 wires. I'm going to cut a black for the negative. I'm going to cut a red for the positive. I'm leaving the rest aside, don't need it. I'm going to remove the insulation. With the help of a little stripper. And now I'm preparing these ends right here. This is one, and this is the second one. Very good. So this one here is the common cathode. And the other one is the common, this was the common cathode, and now I linked all the cathodes here together. On the other side, I'm going to still use the stripper to remove the insulation. Good. And guess what? Right now, we're going to be able to check it. Okay? What's going to happen is I'm going to pick up these two wires. I'm going to do one last check to make sure nothing is shorted. It's not. Very good. And if you can notice right here, this power supply is now 12 volts. I'm going to attach the two wires to it. The black goes to the negative. The red goes to the positive. Okay, I'm gonna put the power on. And apparently you don't see anything for a simple reason. If I take a look, the little guy as a reference, as you can see here, the switch on my left is for the segment D. What if I put it on? This is the segment D. Remember, for one of the old videos, the introductory part for the displays, A, B, C, D, E, F, and G. Next one here is a E. Where is E? It's right here. Take a look, it's right here. Next one they have is F. F is the next one in the top of E. Let's find out. Here it is. Next one is a A. A is right here in the top. Here it is. Next is G. G is the one in the middle. Okay? Let's see. Here it is. And then we have the B, which is right here. Sorry. B. And the last one we have is C. Obviously, if we need it, we also have the decimal point, which is right here in the bottom. Okay? So everything seems to work perfectly. I don't need the decimal point. I leave it aside. Okay? By the way, it's described in the paper right here that for the decimal point they have 5 LEDs. They don't need 10 or 20. 5 LEDs for the decimal point. Okay? So obviously the resistor for the decimal point is going to be different. Okay? It's 220 ohm now because it's 5, exactly like one of the strings. Okay? But if you energize it at 24 volts, they're going to add 820 ohms in series with the string. So this way they're going to limit the current to a low value. Okay? So right now, by having these switches connected, we can obviously create any number we want. Okay? Example, if we want to create a number 3, remember the sequence. For 3, I need A, B, C, D, and G. So I look for it. A, B, C, D, and G. So here, if I look for it, I don't need F, which is the third one. And I don't need E, which is the second one. And here is my 3. Let's say I want to create the 4. Then the 4 is, remember how it is made? is B, C, F, and G. So F is the third one, but I don't need the A, so the A is the fourth one. I put it off, and I don't need the D, which is the first one here, and here is my 4, and so on. So if you do this, unlike the small project where everything was on one little board, all the digits, this time each digit can be configured individually, and you can configure it for any number you want. And that's how it's working. So here, what I just did, what I did was that in the bottom right here, this is the drawing. Of course, I'm going to put it online, don't worry. Here are the switches. And if the switches which are part of the dual inline package, right here, I linked all these together, like this. And that's how I created the common cathode. The common cathode link. Why is the common cathode link? Because here in the bottom are the cathodes for all the segments. And when I close that switch here, that cathode is going to go to the common. And that cathode is going to go to the common, and so on. So I can link all the cathodes to the common. And at the same time, the wires are linked together with the anodes, right here in the top. Okay? So the anodes were right here in the top, related together. The cathodes are here all together, these ones. And I separated the cathodes by the mini-dip switches. So this way I can have a full control over each of them manually. Okay? So for today, we have a manual control for all the switches. But I want to give you more information. Okay? Right now, everything is energized at 12 volts precisely. Okay? But I want you to know what are the voltages you can energize this for, and what's going to be the consequence when you do. So, right now, we're going to put on the ammeter, DC current, and what we're going to do, we're going to insert our ammeter in series with the whole circuit, and we're going to take some measurements and doing just a bit of arithmetical calculation to figure out how can we play with our digits. Okay? Right now it doesn't say big deal, it just says for the 1, 2, 3, 4 segments which are making the number 4, the consumption is 144 milliamps. It's not my point, okay? My point is I'm going to put on all the segments, okay? As you can see, all the segments are on. I may not be interested about the decimal point, but it's going to enter anyway in the tolerance. So 240 milliamps, 233 without the decimal point, okay? So 240 milliamps. I have another one there for you, right here. What does it say? It says that for the 7-segment display size, I'm going to do it as well for the 5 inches size. But for the 7 inches size we're right now on, in the worst case scenario, when all the segments are on, like for the number 8 and the decimal point, even if you don't need it, okay? We're here at 12 volts power supply, okay? We're here at 12 volt power supply. What is the maximum amperage or the maximum current or the maximum intensity for the whole digit in milliamps measured is what you see. Let's take the approximate measurements because 1 milliamp more or less you won't make a difference. So let's consider it 240 milliamps, okay? When you energize it at 12 volt. But in this way, remember that how many LEDs we have for each segment? We have 20 LEDs for the whole segment. However, we're going to do the calculation at the end because actually we have two strings of 10. Remember, we have two strings of 10, okay? So then, 240 milliamps for the whole digit. But what if we energize the digit? Take a look how bright it is. It's very bright. You can go actually as high as, I put it here, 13.5 volt. You're going to see what happens. The current goes a bit higher. So I'm going to adjust it. Let's say 13 volt precisely, okay? 13 volt, I'm going to have approximately 330 milliamps. And if you just increase it a bit more, up to 13.5, it has approximately 370 milliamps consumption. You see? I don't want that big consumption because it's still brighter, but not extremely bright if you compare versus 12 volts we had before. I made it 12 volt again, you know. And now, what if I lower the voltage? Let's say if I make it 11 volt. Okay? It's still bright enough, but the consumption drops dramatically to, let's say, 160 milliamps, approximately, okay? It's 156, let's say 160, okay? I can still drop it. 10 volt. It's still visible, and the consumption drops dramatically to 76 milliamps, let's say 80, okay? Just round it to 80. You can still drop it to 9. You have 9 volts, is not as bright as before. So our display comes dimmer. I want you to see what happens when the voltage drops, okay? It's a very low current, let's say 18 milliamps. And here I didn't put 8 volts because it won't work. It's already too low. If you put it at 8.5, you see it's barely visible. Now it's a very dim, and the consumption is negligible, is only 4 milliamps. Take a look at the difference. 4 milliamps versus 240 at 12 volt. It's a dramatic difference. Don't go any lower than that because you practically won't see it at 8 volts, okay? You see, at 8 volts, it's barely, you can barely realize it's on, okay? So don't ever go there, okay? So I'm going back to 12 volt. 12 volts exactly. Okay, we can make it very accurate. 235 is not far. We rounded it to 240 volt, okay? So, what is the amount of amperage or current per segment? How many segments we have right now? We have 7 segments plus the decimal point. Let's neglect the decimal point. Forget about it, okay? Forget about the decimal point. It's not visible anymore, okay? So let's say without the decimal point, I'm going to adjust it to 130, okay? It's not going to be a big difference. So now, showing you what to do. Considering the original measurements as being for the 7 segments, is 240. 240 divided by 7, 34 approximately, 34 milliamps per segment, okay? And if you want how much amperage or current you have per string, remember there are 2 strings right here. There are 2 strings in parallel, so it's going to be the half of it, 17. So because the 10 diodes for this big digit, they are not 5. 5 are for the other one, which is 5 inches. 10 diodes in series, the current is the same in all the 10 diodes which are in a string. So the current here calculated, 17 milliamps, is actually the current through each diode. Okay? So remember, 5 millimeter diodes like this one. Long time ago when we discussed the brightness of the diodes, we said that anything between 10 to 20 milliamps is good. So 17 milliamps is almost in the middle, like 15. It's very good. So that's the current per diode, okay? And the current per segment is 34. We're going to do the same for all of them. 370 is 54 approximately, 54 milliamps per segment, respectively 27 per string, okay? 330 divided by 7, approximately 47, let's say 48, 47, okay? So 23.5 per string. Here, when the supply is 11 volts, 160 by 7 is 23 approximately, 23 milliamps, 11.5 per string, 80. It's 11.4 milliamps per segment, so 5.7 milliamps per string. Okay, 18 milliamps. It's approximately 2 milliamps, respectively 1 milliamp. And this one is negligible because it's too low, okay? So just to know that in the moment you have the consumption per segment and you divide by 7 to find out how many milliamps per segment, and then from the segment you divide by 2 to find out per string, that's your table. So this is the good information I'm going to put online for you guys. So you're going to know exactly if you want to build a number made of 2 or even 3 digits, you have to calculate your power supply. So in order to calculate the power supply, you have to know exactly what is the consumption per segment depending on the number you want to display at each voltage. So this is the basis for your calculation, okay? That being said, we're now close to the end for our little video. And surely you don't forget about for the next year. Thank you very much, guys. See you in 2 weeks with a video about the brightness control. Bye-bye.